Alright, find all the zeros of f of x equals x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60 given 1 plus 3i is a zero of f. Alright, so I'm thankful for this free piece right here because I recognize this is a complex number, and complex numbers have conjugates, and their conjugates come in pairs. The conjugate is just changing the math operation, so I just have 1 minus 3i. Now, I have a couple of hints here. I have how many complex zeros? What does that tell us then? How many am I missing?
2.
I'm missing 2 others. Okay, it can be possibly 2 reals, or it can be possibly 2 other complex zeros. So the first thing I'm going to do is I'm going to put those into binomials. And if I substitute those in, I'll have 1 plus 3i and 1 minus 3i. And if I distribute the negative, I'm going to get x minus 1 minus 3i and x minus 1 plus 3i. Question. Did I show you guys both methods yesterday?
Yeah.
To multiplying this out? Raise your hand if you like using the big box. Raise your hand if you like seeing that professor's trick. Alright, I'll just use the box. So I'm just going to put a big old box. Notice I have 9 terms because it's a trinomial. 1, 2, 3. And I'm just going to write this other binomial down the side. And now I can just multiply. Class, when you multiply, what do you get?
X squared.
Here?
Negative x.
And here.
3ix.
Yeah, we just call that 3ix, right? Boys, go ahead and multiply.
Negative x.
Here.
1.
And here.
Negative 3i.
Girls, go ahead and multiply. Girls here. And girls here. Class, what is I squared? And if you multiply those, what do you get? So now I'm just going to go through and cancel terms. Here you'll notice that they are opposites, so positive 3 and a negative is 0. Same thing here. So now I just write what I have left. I have x squared minus 2x and positive 1 and a positive 9 give us positive 10. Raise your hand if you got this trinomial so far. Okay. So let's review big picture what we're doing. They've given me this big polynomial. Give you a visual. And I have these 2 polynomials in pink. And here, this polynomial that is our leftover, well, it's actually pink. I still have some binomials missing. Let's see what colors I pick up really good. How about orange? I'm missing these orange ones. So if I divide both sides by the pink polynomial, which actually is just one set of parentheses, then my leftover, after using division, is going to be my leftover zeros. Okay? So let's do that. I have my big polynomial, and now I'm going to do division. Well, I can use long division, but I'd rather use synthetic division. Class, what number am I going to write here?
1.
So just the number in front. Don't forget your placeholders.
Negative,
-3.
negative.
Can you see why I can't use synthetic division?
This is a trinomial.
I forgot that we have a trinomial here. Synthetic division only works when you have a binomial with an a coefficient of 1, right? So like x plus 2. That would work. So let's go to long division, your favorite. This is a great problem because it's good to review all the concepts. X to the 4th minus 3x to the 3rd plus 6x squared plus 2x minus 60. As a reminder, when you're using long division or synthetic division, that's when you want your placeholder of missing terms. Now this is essentially the same thing we've been doing. Class, how many times is x squared going to x to the 4th? Now we're just going to multiply. Class, x squared times x squared. Remember, I am subtracting. One minus 1 is 0, x to the 4th. -3 minus -2. Negative x cubed. 6 minus 10. -4x squared, and bring down this term. How many times is x squared going to negative x cubed? Negative x. Change colors. Negative x. Let's go ahead and multiply. Negative x cubed plus 2x squared minus 10x. I'm going to subtract those. -1 minus a -1, or -1 plus 1 gives you 0. -4 minus 2 gives me negative 6x squared. 2 minus a -10. Opposite of -10 is +10, so 2 plus 10 gives us 12x. And I'm going to bring down this term, -60. X squared goes into negative 6x squared how many times?
6.
-6. So I just multiply. Totally awesome. They're all exactly the same, right? And if they're exactly the same and I subtract them, they are equal to 0. What does it mean? There is no remainder, but here,
It is factorable.
this was what I was looking for over here. Does that make sense? So x, I needed to multiply these, although these are my zeros, okay? I needed to multiply to get that in pink. So I already have two pink. My pink zeros are 1 plus 3i, 1 minus 3i. And now in orange, I have x squared minus x minus 6, and that'll factor to 2 and 3. Which one has to be negative? And then if I solve, I have my zeros are equal to -2, +3, those are the ones in orange, right? And then the pink ones from above, Those are my other two zeros. Those are the complex ones. 1 plus 3i and 1 minus 3i. So here are all the zeros of our polynomial. My two reals and my two complex. 2 plus 2 gives me a degree of 4.